Another strategy for simplifying trigonometric expressions is to change everything into sines and cosines. That's how I want to approach this one. Let's see, we have tangent x. Well, we can use a quotient identity there. The tangent is the sine over the cosine. It's going to look worse for a minute before it gets better, but it's going to get better in the end, I promise. The cosecant is the reciprocal of the sine, so I can use a reciprocal identity on that. This is 1 over sine. Since the cosecant is squared, the sine is also squared. That's 1 over sine squared x. And there's my first term with only sines and cosines. Plus, I'm going to do the same thing to the second term. Tangent x, oh, well, that's still sine x over cosine x. And the secant is the reciprocal of the cosine. So I'm going to write that as 1 over cosine squared x. The secant is squared, the cosine is squared. And yeah, that doesn't look better, except for it's all in terms of sines and cosines, and I'm down to 2 functions instead of 3. Well, next, these are complex fractions here. We have a fraction in the numerator, fraction in the denominator. Let's deal with those. This is division at the end of the day. So dividing fractions, I'm going to take the top and multiply instead of dividing. Change multiplication to division, the reciprocal of the bottom. So if you heard keep, change, flip at some point in your past, that's what that is. There's the first term. Here's the next term. The top, change division to multiplication, and the reciprocal of the bottom. Well, that's a little better. At least they're not complex fractions anymore. Let's see what simplifying we can do. Well, I'm going to notice I have a common denominator, cosine x times 1, cosine x times 1. So now I have 2 fractions with a common denominator. I can just add their numerators together. Let's see what happens when we do that. So I got sine x, maybe we'll use the right tool, times sine squared x. You can multiply them together if you want to, plus sine x times cosine squared x, all over the common denominator. Now I have 2 terms on the top, and they each have a sine x in them. Well, I can factor that out. So that was another strategy that we mentioned, is factoring. Now I'll have on the top sine x times, from the first term, sine squared x, and from the second term, cosine squared x, and my denominator was cosine x, and it still is. Well, sine squared x plus cosine squared x, there's an identity for that. Pythagorean identity says sine squared x plus cosine squared x equals 1. So instead of all of that, I can write 1. Sine x times 1. Well, sine x times 1, that's sine x, cosine x on the bottom. And we have a better way of saying that. Sine x over cosine x, quotient identity, that's tangent x. And there's my simplified version. If you looked at the beginning and said, well, I don't want to use sines and cosines, I want to get a common denominator and add those 2 fractions together, that's totally fine. All roads lead to Rome. That road will lead you to Rome. You will end up with tangent x if you try it that way too. So just because you try something different than somebody else that you're talking to about a problem doesn't mean one of you's right and one's wrong. There's a really good chance that everybody's right. More than one way to do many of these. Whatever way you do it, you will end up with tangent x.